Computer Science A, Unit 8, Lesson 1, 2D Arrays. Here's the surprising thing. This unit is only one lesson long. This lesson, or this unit, and this lesson has the objective that you understand how the two-dimensional array structure in Java may be represented by a table with rows and columns, and learn how to declare and initialize and access data from a two-dimensional array in Java. Now, let's see, whoops, sorry, mouse didn't want to work there. Recall arrays, the general creation. You have type, brackets, name, new, type, and then you give it a length. An example, int, an array of numbers, a new array of integers, 10 long. And then we've got Booleans and strings. Using arrays, well, for int x numbers, x is set to x times x. Basically, I'm going to take, and for every element, I'm going to square it. And then system.out.println int 3. What will the output be? Drum roll, please. Bang, it's going to be 16. Okay, this says for every integer x inside of numbers, I want you to square it. Now remember that we can change the primitives. We can change things in arrays. So we wind up with from 1, 2, 3, 4, 5 to 1, 4, 9, 16, 25. So output is 16. Now, multidimensional arrays. These are arrays of arrays. So here, and think of it as a matrix. Int, an array of arrays of values, is set to 1, 2, 3, 4, 5, 6, 7, 8, 9. This is one array. This is the second array. This is the third array. Here, the first array points to these three elements, the next array to these three, and the third array to these three. And it's essentially a matrix. You can declare this either way, all on one line or on two separate lines. This way, where you're putting it on five different lines, it's a little bit easier to see that it's a matrix. This is maybe a little harder to visualize. Now, creation with default values. Remember that the default values for double or ints are going to be 0. So here, if I do double and then an array called grades, new double 3, 5. That means I want 3 rows with 5 columns. This first number is the number of rows. The second is the number of columns. So I've got 3 students, each with 5 grades. 1, 2, 3. Think of a grade book, what it would look like. Now, operation, grades, student 0, third grade is going to be 98.3. Student 0, the third grade, or the grade in location 3, is 98.3. Grades 2, 0, 99.4. That means my second student, or the one in row 2, remember we start at 0, and then location 0 gets changed to 99.4. Okay, so it's really not crazy difficult, okay, but you've got to understand how to do it. So if we take a look at this, grades, that's the name of our two-dimensional array. That's what grades is. Grades sub 2, that's going to be this third row, or the row that's at number 2. So row 2 of the 2D array. And we say row 2, remember it's row 0, row 1, row 2. Grades 2, 0, this is the grade that is in row 2, column 0. Okay? And let's see here if I can do this. In column 0, first column, if you will. Okay? Now, it does get a little bit confusing because when we start talking about 0, 1, 2, 3, first, second, third, it is a little bit confusing. So I'll try to be clear as I go through this. Please stop me, ask me questions if you don't understand. Okay, the number of rows. The number of rows, there's 3 rows, numbers 0, 1, 2, and 3. That's grades.length. Now, if that's grades.length, how do I get the number of columns? Well, that's grades.length, not length. Huh? No. It's grades sub 0.length. Length is not one of the arrays. Okay? So remember, let's see if I can go back here. This one is an array of arrays. So I need to take one of these, and I could actually have done grades sub 1.length or grades sub 2.length because I made these all the same. Okay? If you said grades.length, that was a good guess, but it's not quite. You got to think about grades sub 0. This is an array that has, this is a student who has some number of grades. Okay? Now, traversing a 2D array, row major versus column major order. Below is a table showing the quantity of items sold at restaurants in Skokie Land over a week. Assume this data is stored in the array below. So we have an array of products. These are objects. And our products, we have the restaurants, McDonald's, Burger King, and Wendy's, and we have burgers, fries, and salads. Now notice that row major is how many burgers are sold in each one of the 3 restaurants, the fries, the salads. Column major is everything sold by a particular restaurant. So to determine the total number of items sold by McDonald's, we would need a loop that adds up every element in column 0 or a column major. So let's take a look at this. I would have total number of items is 0. Then I would want to add to that everything in 0, 0. Then in 1, 0 and 2, 0. Okay, remember that these are the rows, these are the columns. So in order to do that, int sum is set to 0, I initialize it. Int I is less than products.length. These are my products. I'm going to increment by 1. And McDonald's is everything in column 0. So the column stays 0. I'm only incrementing the row. Pause the video and make sure you understand this. Traversing a 2D array, row major. Below is the same table showing the quantity of items sold at restaurants in Skokie Land over a week. Assume the data is stored in the array. Now again, remember that the products are per column. Okay, or the products go across, the rows. The columns are how much for each restaurant. So to determine the total number of burgers sold, we want a loop that adds up every element in row 0. So we could just say sum is set to 0, sum plus equals products 0, 0, 0, 1, and then 0, 2. I don't know why I didn't have that guy in here. Oh, I did. Look at that. Somehow he just got bumped over. We'll just have to move his happy self back here. Boom. Okay. We'll save that so in the future it'll be in the right spot. Now, here's a general way. We set column to 0. Column is less than products sub 0 dot length. So this row, products, all burgers are in this one, and I want the length. So however many stores are selling burgers. C++. Sum plus products sub 0, C. The fun way, okay, this is a way to add them all up in a for each loop. Okay? And we would just add all these little guys together. Now, probably your clearest way to do it is this way. This manual is tiring and ugly when you start talking about lots of rows or lots of columns. Now, traversing a 2D array, row major versus column major. Below is a table showing the quantity of items sold at restaurants. Same table. To print out how many items were sold by each company. You want row major processing, okay? So here, store is set to 0. Store is less than products, sub-0 dot length. Right? And you're going to go through. This adds column and moves to the next column. This adds rows and moves to the next row. So this will print out all the burgers, then all the fries, and all the salads. This one will print out all the McDonald's, all the Burger King, all the Wendy's. Okay? Now, if I want to, I can nest things in together. And so I can go through the whole thing. And again, it depends if you want to go row major or column major. But for R is set to 0, so I'm at row 0, and I'm less than my multiplication table dot length, R++. For C is set to 0, multiplication table sub 0 dot length, so it's this long. C++, multiplication table RC is set to R plus 1 times C plus 1. So here, columns fill first, and then the rows. So the columns, and then the rows. So I'm going to get 1, 2, 3, 2, 4, 6, 3, 6, 9. For row is 0. Okay. Column starts at 0, so I'm going to do 0, 0, then 0, 1, then 0, 2. Notice here my column is changing. I jump out and I increment my R, and my C goes back to 0. So then I'm at 2. Okay? Count to 9. And next is set to 1. So here, R is 0. R and C. So R is 0. To count 9 dot length, C is set to 0. Count to 9, RC is set to next, next plus plus. So remember, next is 1. So if I look at this, I've got count 9 RC, so 0, 0 is going to get 1. Then what happens? Oops. Then next becomes 2. And I go up, and my C becomes 1. So 0, 1 gets 2. Then next becomes 3. C becomes 2. 0, 2 gets 3. Then 3 becomes 4. Then count goes up to 3. But 3 is not less than count to 9 sub 0 dot length, which is 3. So it falls out of this loop and comes back up here. And now R is set to 1. And C goes back to 0. And next is still sitting there at 4. So then it's going to come through here, and I'll put 4, and again 5, 6, get to the end, and go around again. Nested loops are how you fill out a matrix. Count to 3. Okay, here, follow this through. My next is 1, column is 0, count to 3, RC equals next. 1, 2, 3. And then when I come back outside of this and I increment my row, I reset next. The difference between this one and the previous one, this next, notice it came before the loop. In this one, next is inside this outer for loop. So it constantly gets set back to 1. How would you order the numbers in the matrices change if the outside and inside loops were switched? It would be simple. The rows will fill first, so the last example would look like this. Instead of being 1, 2, 3, 1, 2, 3, 1, 2, 3, you'd get 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3. That's all. Using a for each to iterate over a 2D array in row major. It does not work for column major, only for row major. So for double row temps, for double value row, system.out.print, system.out.println. So you're going to go through and you're going to print out the entire row, and then you'll do a print line. So you'll do a line return and come back. Okay? Try doing this. Higher dimensions, you can have higher dimension arrays. You can certainly do that in Java. You can have an array of arrays, which makes it three-dimensional. Think about locations inside a cube. So if I wanted something that was a 4 by 4 by 4 cube, and then I wanted to change at 0, 1, 2, and I wanted to set it to 5, row 0, okay, column 2, or column 1, depth 2, I would set it to 5. This is very difficult to think about, to look at. You can't always see inside the cube. And good news for you all, this is not tested on the AP exam. So you can put your hands together and clap that one out. Now, that is the end of lesson 1, and it ends unit 8. The biggest takeaway here, if you're traversing through, whether you're printing, changing, looking at, testing, updating, or filling a two-dimensional array or a matrix, you either pick to do it row major or column major, and you need nested loops. Okay? So you see nested loops, should cue you in that there might be an array. Not always, but there might be.